Hello everyone. Today's topic for us is partial differentiation. We've already studied what is a derivative and what is differentiation with respect to a single variable. Suppose we had a function of one variable, then we can differentiate only with respect to that variable, so that the differentiation simply means for us if f is a function of x, then dy by dx. Now suppose we have a function of two variables that is equal to f of x by f is a function of two variables x and y. Then when we say that we can differentiate this function, I have to specify with what I am differentiating. Am I differentiating with respect to x or I am differentiating with respect to y? And if I keep this x constant in the function, x is treated as a constant, then the function becomes a function of y, so that I can differentiate it with respect to y, and that differentiation is called as the partial derivative with respect to y. Similarly, if I keep y fixed and then the function becomes a function of x, so that I can differentiate with respect to x, so that I get the partial derivative of z with respect to x. So that the partial derivative with respect to y, we denote it by dou z by dou y, or f suffix y, or dou f by dou y. And this is the definition of the partial derivative. Dou z by dou y is equal to, when I differentiate with respect to y, I am going to keep x constant. So the derivative becomes limit delta y tending to 0. F of x is as it is, only y becomes y plus delta y minus f of xy divided by delta y. This provided the limit exists. Only if the limit exists, then I can find the limit so that the partial derivative will exist. Similarly, the partial derivative of z is equal to f of xy with respect to the variable x is denoted by dou z by dou x, or fx, or dou f by dou x, and the limit definition is given like this. Because we are differentiating with respect to x, y is kept as constant, so we get only limit delta x tending to 0, f of x plus delta x comma y minus f of xy divided by delta x, provided that the limit exists. These derivatives are called as the first order partial derivatives of the function z is equal to f of xy. Now, if I take the partial derivatives dou f by dou x and dou f by dou y again and differentiate it, then I get the second order partial derivatives. So I can take dou f by dou x and differentiate it with respect to x again or with respect to y. So if I differentiate with respect to x, then I am differentiating twice with respect to x. So the partial derivative I'll be getting is dou square f by dou x square, or simply I can write it as fxx. If I take dou f by dou x and differentiate with respect to y, then it becomes dou square f by dou y dou x. This means first I am differentiating with respect to x, then I am differentiating with respect to y in the order from right to left. Or in this notation it is fxy. Fx was already there, I have differentiated with respect to y. So this is fxy. In this notation it is from left to right, fx first and then y. In this notation it is from right to left, x first and then with respect to y. Similarly, if I take dou f by dou y and differentiate with respect to x and y again, with respect to x it becomes dou square f by dou x dou y, and with respect to y it becomes dou square f by dou y square. The order here is from right to left, first dou y, then dou x. Here it is from left to right, f y x. So these are the partial derivatives of second order. I can also take partial derivatives of higher order, and then a result worth mentioning for us is if the function is continuous and possesses continuous partial derivatives at the point x comma y, then it does not matter in what order I am differentiating. I can differentiate with respect to y and then with respect to x, or I can differentiate f with respect to x and then with respect to y. Both are going to give me the same value. We are moving on to problems. If f of xy is equal to tan inverse of x by y, find dou f by dou x and dou f by dou y, and verify that dou square f by dou x dou y is equal to dou square f by dou y dou x. Okay. To find the first order partial derivative and the second order mixed derivative. F of xy is tan inverse of x by y. I should first find dou f by dou x. So how do I differentiate? When I differentiate with respect to x, then y is treated as a constant. This y becomes a constant. Then tan inverse, the differentiation is 1 by 1 plus x square. If it is tan inverse of x, then it is 1 by 1 plus x square. Tan inverse of x by y becomes 1 by 1 plus x by y whole square into differentiation of x by y, and keeping y constant, that means 1 by y is a constant and differentiation of x becomes 1. Simplify, take the common denominator y, and y is going to get cancelled, so that 1y goes on the numerator and it becomes y by x square plus y square. Similarly, differentiate f with respect to y. Okay, I am keeping x constant now. Tan inverse becomes 1 by 1 plus x by y whole square. X is kept constant and I am differentiating 1 by y, which becomes minus 1 by y square. Both these y square get cancelled, so what is left is minus x by x square plus y square. What am I doing here? We have to take the common denominator, so this becomes x square plus y square, and that y square gets cancelled. And the mixed derivative, dou square f by dou x dou y, as we discussed, what is the order? First with respect to y and then with respect to x. So I have to take dou f by dou y and differentiate with respect to x. Dou f by dou y is here, minus x by x square plus y square, and differentiate with respect to x. So what happens when we differentiate? We are using the u by v rule now. Minus is kept outside. Denominator into differentiation of the numerator with respect to x becomes 1, minus the numerator into differentiation of the denominator with respect to x. X square becomes 2x and y square is treated as constant, so it is 0, divided by denominator square. And here it becomes x square plus y square minus 2x square. So this is x square minus 2x square becomes minus x square. So y square minus x square divided by x square plus y square whole square. Put that minus inside, I will get minus into minus plus x square minus y square divided by x square plus y square whole square. Similarly, take dou f by dou x and differentiate with respect to y. We are going to get dou square f by dou y dou x. You can look into the differentiation and we can observe that both the answers are same, so that the mixed derivative value is equal to same. The second problem, I think it is not that much visible. If f of xy is x power y plus y power x, show that dou square f by dou x dou y is equal to dou square f by dou y dou x. What do we have? F of xy is equal to x power y plus y power x. I have to find the mixed derivative. So I should find dou f by dou y first, dou f by dou x first, and then interchange the variable of differentiation. Okay. Before we go into that, let's make an observation here. If I have d by dx of a power x, the variable is on the power and the base is a constant, d by dx of a power x, then the differentiation is a power x log a. If I have d by dx of x power n, the base is a variable, the power is a constant, then it is differentiation is n x power n minus 1. So there are two things here. One is constant to the power of variable and one is variable to the power of constant. Why I need this? Because when I have x and y both on the power as well as on the base, and I'm going to differentiate keeping one of the variables constant, therefore both the cases will arise for me. Base can be sometimes a constant and power can be a variable, or power can be a constant and base can be a variable. Therefore, depending on the derivative what we are taking, we should use the differentiation formula. Now f of xy is x power y plus y power x. We are going to differentiate this with respect to x. That means y is constant and y is constant. Here power is constant, here base is constant. Okay. So here power is constant, that means I am going to use the second formula. So it is going to give me y x power y minus 1 plus. Here y is constant because we are differentiating with respect to x. Base is a constant. So if base is a constant, a power x becomes a power x log a. So the differentiation of y power x becomes y power x log y. So dou f by dou y now. Now we are keeping x constant. So this is base is constant. So differentiation becomes x power y log x using this base is a constant. And here power is a constant because we are differentiating with respect to y, power becomes a constant here, so it becomes xy power x minus 1. So take this and differentiate again. If I want dou square f by dou x dou y, then I should take dou f by dou y and then differentiate with respect to x. So dou by dou x of dou f by dou y we have written over here. Now we will take the differentiation again. We are taking y constant because we are differentiating with respect to x. So now this is a product rule here, u into v format, so that when I differentiate, first term is kept constant and differentiation of the second term with respect to x log x becomes 1 by x, plus second term is kept constant, differentiation of the first one. First one, how is it now? It is variable to the power of a constant, so that the differentiation is of this y x power y minus 1. So first term differentiation is over. Now the second term differentiation, again a product rule. First one, keep it constant. Differentiation of the second one with respect to x, this is constant to the power of variable, so it becomes y power x minus 1 log y. Plus second term is kept constant, differentiation of x with respect to x becomes 1. Rearrange the terms, you are going to get this as the value. What will you do? You will write this as x power y minus 1, and this is kept as it is. This is also kept as it is, keeping y power x minus 1 constant. Here I can take x power y minus 1 constant. Similarly, differentiate the dou f by dou x with respect to y. You're going to get this answer, and you can compare the answer and see that both the mixed derivatives are same. Now we will move to the third problem. If z is equal to 1 minus 2xy plus y square to the power of minus half, show that x dou z by dou x minus y dou z by dou y is equal to y square z cube. Show that questions are easy because you already know what you have to get as an answer. So we'll start with the left hand side and show that it is equal to the right hand side. What do I require? I require dou z by dou x and I require dou z by dou y. Take z, dou z by dou x, that means y is kept constant. First we have to differentiate the power. Anything to the power of minus half becomes minus half into the term to the power of minus half minus 1. So that is minus half into 1 minus 2xy plus y square to the power of minus half minus 1 into differentiation of the inner term with respect to x. 1 is going to be 0 minus, as it is, y is kept constant, 2 is constant, so 2y is constant into differentiation of x is 1. Y is entirely a constant, therefore the differentiation is going to be 0. So it is minus half. This term minus half minus 1 becomes minus 3 by 2 into minus 2y. Minus into minus becomes plus, 2 into gets cancelled, so it is y into 1 minus 2xy plus y square to the power of minus 3 by 2. Or I can write this as minus half, I can keep in the power inside. I can write this term to the power of minus half. This 3 I can write it as whole cube. This is nothing but my z only. 1 minus 2xy plus y square to the power of minus half is z only. So this becomes yz cube. Then dou z by dou y. As usual, the power is to be differentiated first. Minus half into the term to the power of minus half minus 1. So this will become minus 3 by 2 here. Into differentiation of the inner term with respect to y. 1 becomes 0. Minus 2x is constant. Differentiation of y is 1. Plus differentiation of y square becomes plus 2y. And 2 I can take common. Gets cancelled over here. So what is left? I can multiply this minus inside. Minus into minus becomes plus. Minus into plus is minus. So this becomes this full term into x minus y. And as we have done above, This I can write it as minus half to the power of whole cube. So this becomes z cube into x minus y. Then we will construct the left side, x dou z by dou x minus y dou z by dou y. So x into dou z by dou x is yz cube minus y into dou z by dou y is x minus y into z cube. Open the brackets, this becomes xyz cube minus x into y into z cube, minus into minus becomes plus y square into z cube. Xyz cube, it gets cancelled, so what is left is y square z cube. So that is what we wanted to. Next, the fourth one. If u is equal to phi of y plus ax plus psi of y minus ax, show that dou square u by dou x square is equal to a square into dou square u by dou y square. Now here, it is not simply a function given to us. The function definition is not given to us. It is simply given u is a function which is a sum of two functions, phi and psi. Phi any variable, that is y plus ax. Inside the variable is y minus ax. Okay, and the definition of phi and psi is not given to us. Only the variables are given. In this case, how do I differentiate? Now, I want u with respect to x twice, u partial differentiation with respect to y twice. Therefore, u with respect to x, the differentiation gives me phi becomes the derivative of phi. Okay, so phi becomes phi dash of y plus ax. Then by chain rule, I should differentiate the variable also. The variable differentiation becomes y is constant, so it is 0 plus a is kept constant and differentiation of x is 1. Similarly, plus psi becomes psi dash of y minus ax and differentiation of y minus ax becomes, this is 0 minus a into 1. So simplify, 0 plus a is a, therefore a into phi dash minus a into psi dash. Differentiate this again, a is constant. Now differentiation again, phi dash becomes phi double dash of y plus ax into differentiation of y plus ax is going to be a. Y is constant, a is constant, differentiation of x is 1. Minus a is already there, psi dash becomes psi double dash of y minus ax and differentiation of y minus ax is again minus a. So a and a square minus a into minus a plus a square into psi double dash of y minus ax. Similarly, take u, differentiate with respect to y. Phi again becomes phi dash. Okay, and differentiation of y plus ax with respect to y, this is 1. A is constant, x is constant, so that is going to be 0. Plus psi becomes psi dash of y minus ax, differentiation of y minus ax with respect to y. Y becomes 1, this is going to be 0, so this is 1. So it is phi dash of y plus ax plus psi dash of y minus ax. Differentiate again. Phi dash is going to be phi double dash of y plus ax. Differentiation of y is 1. This is going to be 0. Plus psi dash becomes psi double dash of y minus ax. Differentiation of y minus ax. With respect to y, this is 1 and this 2 are constant. So this is 2. So this is phi double dash plus psi double dash. Now if you compare dou square u by dou x square and dou square u by dou y square, this is nothing but there is a square extra over here in dou square u by dou x square. So that dou square u by dou x square is the same thing, dou square u by dou y square multiplied by an a square, which